Hello everyone, my name is Rajesh Kumar and I'm your DevOps SRE DevSecOps coach. Okay, so last session which I discussed about what is Docker. Okay, so I think we discussed about what is container management tool. Docker is a container management tool. Then we discussed about what is container also, and then we had container workflow. So container workflow means what we did. So we created a container, we started the container, we stopped the container, we pause the container, we unpause the container. So these are the things which we did. And after that, we use the container. So these are the something which we did last session. Okay, so from here, we'll move on to the next step. So let's go ahead. So now this is a container. So now what we are going to teach you, I'm going to teach you is how to create an image. Okay, that is the topic which we'll have now. And then second topic is how to share an image. Okay, this is something which I'll teach you. So first of all, what is an image? What is an image? Docker image. So last session we used two Docker image, but this session we'll create an image. So what is a Docker image? So if you remember Docker image where I said it has a root file system, that is the root file system, plus user file system, and plus application file system. So when I say root file system means it can be Ubuntu or CentOS or Fedora Debian. Root file system means one user has to be there, so by default it's root. Okay, root. And then applications can be anything. So it can be ls, it can be java, it can be apache. It depends on your need actually, right? So that is something which we have. So this is called image. Are you comfortable with it, all of you?
Yes.
Okay, so now I'll give you little bit different definition today, because this definition I created so you can understand the container very easily. Container very easily. Okay, but today I'll give you different definitions. So image is nothing but uh, collections of image is equal to, understand this way, this is a file system 1, this is a file system 2 ls, this is the file system java file system 3, and this is the file system 4 apache. So here these are the file systems, separate file system. Okay, so here what I'm trying to say is image is a collection of file system. Let's put it up this way. This is one file system, there's another file system, there's another file system, there is another file system. All are file system. What is the file system, by the way? What is the file system?
It's a folder, okay, where we can hold all the
Directories and
files.
files. Yeah, directory and files.
Yeah.
So so here in image, in a Docker image, you have multiple file system. What it contains then? So here you will have a root file system, Ubuntu, Fedora, and all kind of things. Here you may have a Java. Here you may have some applications. One. Here you may have application two. So see that root file system is in separate location. Java is in separate. Let's say this is a Tomcat and this is application. So here you understand this way. In order to run application, you need a Tomcat. Tomcat to run you need Java, and Java to run you need root file system. I hope you remember that there's one topic which I covered last session. What are the resources you need to run any application in order to define the container? Okay, so that is something which you have it. So what is image? So image is a collection of file system. Now these are separate file system. Okay, let me show you, then you'll have a little bit of visualizations. Go for putty, and here credentials, purpose, username is Ubuntu, and now should become a root. Now this machine you have a few images. I need to check which are those. So Docker images, and you see here there's a two image, HTTPD which I used last week, last day session, and then this one. So where this image is located, the file layers. How do I see that how many layers we have in this image? Oh, sorry, my files. What is this called? File system. So you can see using the Docker inspect this command and HTTPD. So how many file system you have for HTTPD image? Enter. 1, 2, 3, 4, 5. These are the one. Now where exactly that located this file system? So Docker info. In the Docker info, you have one location here. So go to this location, and your this file system will be there in this directory, overlay 2. You have to remember it. Okay, am I recording this session? Yes, good. So overlay 2. Look at this here. These all are file system, just like this. 1, 2, 3, 4. 1, 2, 3, 4, 5, 6, like this. You want to see, you want to go inside that and see that what exactly. So go inside this div directory. See here you have only home and only temp. Only these two file directories are there in this machine. See, under the home you have rundeck, this one, and these are the files, and under the temp this is the files. Something related to rundeck, which I had a morning session rundeck. So I created one container of rundeck. That is one. So now you understand that one image will consist of multiple layers, multiple file system, and each file system will have a separate file. Are you understanding? All of you?
Yeah.
Yeah.
So, but guys, in Docker, we don't call it a file system. What we call it? And it's a real word. File system is a real word. For example, car, you don't call car, you call it Maruti, something like that in India if you are from India. So same way. So here, these are the file system, but we call it layer. Please remember that. What we call it? Layer. Why? Because these all are having a relationship. Apache parent, this is Apache child, no, this application child, parent is Tomcat. This parent is this one. This parent is this one. So they are layered over the each other, not physically, but visibly, virtually, visually. So here you see that all are separate location. Let me show you. Look at this. These all are file system separate. This one could be a child of some parent. You have that relationship. So here this is a child, this is a parent, this is child, this is a parent, this is child, this is the parent, and this is a super parent. Means this has no parent, like that. So we call it layer actually. And that's the reason if you see that, if I do inspect command, if you remember that, somewhere I run it, here, these are the layers. Here layers, layers, layers. What we call it? Layers. Are you comfortable, all of you? Hello?
Yeah.
Yeah.
So guys, last session I created a container, Docker run image name. So what happens? I'll tell you. Please hear me out. I'll not complicate too much. When you say Docker run HTTPD or Docker run Ubuntu or Docker in Python or Docker in this, you try to create a container. What happens? All this image layer get merged into one layer, and that is getting mounted to the container. Yes, this layer, whatever you have, this file system, you have all these four merged one actually. If you want another container, same thing will happen here. So basically what you do, you modify inside a container, basically you modify here. This is the merged one. Not here, not here, not here, not here. Let me show you. So for example, how many containers I'm having? Let me check. I have nothing. What I'll do, I'll create one container, Docker run -d httpd. I created one container. Look at my screen. There is one container running, and you want to see this, which is the merge one, df-kh. Look at it. This is the one. Look at the last one, merged. Location is also overlaid too. This is the merged layer. So what happens when you create a container? All this layer get merged into one, and that get mounted to user, and that become a container actually. So whatever you do, you do inside this and all. You create one more container, and you see here, two merged. Understood now?
It is -d. Docker run -d.
Yeah. Docker run -d to create a container. Understood? Okay. So now we have understood that image is having nothing but a multiple file system. Each file system we call it layer. When you create a container, all the layer of that particular image get merged into one, and that get mounted to container, and that is what we are using. Make sense? All of you? Hello?
Okay.
So now the question was different. Question was
Yeah.
how to create an image, new image. So actually this question is not valid question. You should technically call it how to create a new layer. This is the question. How to create a layer. Because if you see that here, let me tell you. Here you have a 4 layer, 1, 2, 3, 4. In the 4 layer, how many images you can create? Let me show you. If you, this layer, if you brand it, let's say X is the image name, and this will have a base image. Base image is can be Ubuntu or Fedora. Now you combine these 2 layers and make it, name it Y. So this will have a Java. So base plus Java, 2 layers will be there. If you combine these 3 layers, then you will have a Tomcat. Tomcat will have 1 layer, 2 layer, 3 layer. An application, which is your 4 layers. So here 1, 2, 3, 4 image you can create separate one. It's up to you whether you want the base image or with a Java or with a Tomcat or with application. So now if you want to create a new image, which I said just now, you have to create a layer. So what you have to do, understand that very simple way. Create one container from the whatever the source image you want. You can create a container from the this image also, this also, this also, this also. But right now I'm considering this one. So you create a container, all these 4 layers will come and add your extra files which you want to add it. This merge layer, you have the collection of all these files plus extra files. Okay. Now extra files, remember extra files which you added, extra things you did it, you have to commit it and create one more layer, and that commit you did it and created one more layer, and this you call it M. So this will have only extra file X file which you added in a container. App is here, Tomcat is here, Java is here, base is here, and now all these layers consist of M image. Are you understanding? Hello?
Okay.
So what I need to do? So in order to create an image, in order to create a new image, have a base image and container ready. So now let me go and take one image creation process. So what I'll do, I'll create one container, Docker run -itd Ubuntu. This is the base image I'm taking out and enter. So here I got one container. You see that this is the container. Okay. Now in the inside a container, I go inside a container. How? Docker execute -it. I taught you last session. Bin bash. I went inside the container. Mind it, this is the virtual machine. This is a container. I'm inside a container and I want to do something. What do you want to do? So install a Git. Git is there? No. So let me install. So it's a Ubuntu container. So apt will work. Get install git -y. It says Git is not there. Package. So what you need to do? Update it. Container. Done. Now I'm installing a Git inside a container. So on top of that, this layer, I wanted to have a Git. And here you see now inside a container, Git is there. Like that, you install any files, copy any files, do whatever you want to do. Theoretically, you can do anything inside a container, whatever you want to see, and come out of the container. Now, if you see that here, Docker PS, this container which I created from Ubuntu, now I got inside that and install the Git. But in this container, you have a Git installed. So now Ubuntu, how many layers we have? Let me check. Docker info inspect, sorry, enter. 3 layers, no. one layer is there, only one layer in this. Because of base image, no, it is having one layer. So now if I create a new layer which will have a git and so on, so I want to commit it, I want to create a new image out of it. So docker ps docker commit. Which commit? Why you are committing? So it has a update also, and it has a ubuntu also, and it has a git also. Who are you? Author Rajesh. Which container you want to commit? This one. What image? I'll just keep it the same. So mind it here, this is the image name will be created from the container of this one which has a git. And now you see here, I got the image. Look at this. Base is Ubuntu, which is 77 MB, but new image which I created, which has 193. Now, if you remember that Docker history, there's one command Ubuntu. So what is the last commit? See, this is Ubuntu, mind it. This is the 3B, something like that. If you do the Docker history or commit history, if you try to find out, see here. Till here in this image, you have Ubuntu. This is the layer extra which got added, which is of size of 115 MB and so on. So what I did again, I created container, modify the container, commit the container, all the delta which was written in the container. For that, using that one new layer got created and with labeled with a new image name. Did you understand that? That means in this image, if you see that, in this image, you have a git. In this image, you don't have a git. Are you understanding, all of you? Hello?
Yes.
Okay. So now guys, this is the image we created, new one. Now I created this image using the container. Can I use this container and see that if you have a git inside that? I got this container. Look at my screen. This container from this image. Can we check the git is inside that? So docker exec container ID git. Yes, is there. In that container you have a git. Now, so this is the way you can create a new image. Any questions so far? Any questions
No.
so far?
No.
Okay, good. So guys, now this is a manual ways to creating an image. Whatever I taught you is manual way to create an image. How to do automated way. So for automated way, you have to use one file which is called Docker file. Docker file. This is the file. And in this file, you have to write all the instruction. Okay. Let me write all the instruction. For example, whatever you did manually, you are going to write the instruction. So what is the base image you want? Ubuntu. Who are you? Maintainer. Rajesh Kumar. DevOps. Rajesh Kumar .xyz. What you want to do inside that container? Run. What run? apt get update. Remember that update I did it. Do you want to run something else? Yes. Run. What? Install git. So this is the something which we did it right manually last time. Correct now? All of you? So this is something which we did it. So let me create a container from image from this new image. This is automated process. What I'll do, I'll create one directory, Raj, go inside this, and here vi docker file, enter, paste it. This is your Docker file. So here you have 1, 2, 3, 4 statement. Out of which 3 statement new, this is from the base. So can we create an image from the Docker file? Yes. How? Docker build command. So Docker build command, we will use it. -t for the image name. Raju. I'm creating the Raju1 image name. Okay. And where is your Docker file? Context location dot. Always remember, enter. So this is the automated way. If you want to create a Docker image, automated process, not a manual, you can use Dockerfile. Okay. So this is the stuff. Now, do we have a Docker image? See here, Raju1 has come. If you look at this same image, same size. Why? Because something similar we did, no changes actually. So this is the way you can create a Docker file. Now, can we extend little bit more? Yes, you can copy some files from the base machine. So let me create a one file, index.html. Copy some file from index to where? Temp location. You can install some Apache software also. It's Ubuntu, right? So install Apache 2 -y. You want to set some environment variable env Java home is equal to tmp Java, anything you can set it up. Do you want to create a users? Yes. So here run what? User add what? Rajesh. Do you want to run container as a Rajesh user? So remember that if you see that here, look at my screen. Right now container is running with a root. How? Let me show you. So Docker exec it container bin bash. See, it's running as a root. Okay. So I am creating one user here, Rajesh, Linux command. And then after that, I'm running user Rajesh. So these all things now what you are doing in the image, you want to run as a Rajesh, you want to set environment variable, you want to copy some files, you want to run install git here, Apache here, update here, all this thing. So whatever you want to see in image, you write the code like this. Now we'll say, Rajesh, how do you remember this? From, maintainer, run, copy, env, user. These are the small list of instructions you have. Some of this I'm using, 2 or 3 extra will be there, which you can use it. Not a great thing. So let me create a new image now. So here, because Docker file is there, I cannot use that same name. So Docker file 1. Okay, enter, save it, and build command. I have to change a little bit of it. So this file, this is the image name Raju2, and your file name is Docker file 1. This way. So if the file is non-Docker file, you have to use -f, enter. And now you see here, guys, look at my screen. You have Raju 2, which is you have it 249 because it does something extra also. Are you understanding, all of you?
Yes.
So now I'll create one container from Raju and validate it. So Docker run -itd, because the base is here. I created one container. and this is the container which is from the Raju 2. Let me check one by one. Execute this one. What do you want to check? Git is there or not? Is there? Index.html is in tmp file or not? Tmp location or not? ls tmp is there. Apache is there or not? Which Apache 2 is there? And environment variable set or not? env c java home is there. User is there or not? So what is the location? More. See, I forgot. etc pswd. See, Rajesh, last user. And then last thing, whether it's logged in as a user or Rajesh or not. ID, then next command. You have it. Understood, all of you?
Yes.
So now I'll show you one production ready Docker file. So you'll have a little bit confidence. Okay, so let me show you. Jenkins, you know that, right? One application which I'll teach you. But Jenkins, you can have it image also. How that image has been developed, let me show you. So here, this is the latest, and you see this is the Docker file. So this Docker file only has created an image of Jenkins. So here you see from run. You understand that? I use this run command. Now ARG is doing what? ARG is like argument to the image creation. Means you can say variable. So here user, instead of, see what I did, hard coded, right? Instead of that, what you can do, you can set that one place, and dollar user you can use, see, multiple places, just to avoid the duplicate. See here. So ARG for variable setup, which you can use it. Environment, run, volume just ignore it, run, env, run, copy, arg, env, arg, arg, run, env. So this is your Docker file. So like that, you will write a Docker file and try to automate the process. Are you understanding, all of you?
Yes.
Okay. So last thing what we have in this Docker file, you see here, there is one entry point is there. Okay. So here you have entry point, Bintini. This is the one, and I want to show you one, two also. So Docker Hub Ubuntu. So let's go for this. How the Docker Ubuntu image has been developed. Let's look at it. Where is the latest? I can't locate it. AMD64. Here it is. And where is the Docker file? Wait a second. GitHub. Why they are linked to launched pad? Hold on a second. Uh, Let me search in Google. It will be better. This is the one. Yeah. Look at the Docker file and look at the last line. What is this? Last line? Hello?
Hash.
Bash. So what is this? Someone is using bash. Someone is using Bintini. Let me show you Apache also. Apache, the one which we tried last time. So GitHub Apache 2 Docker file. I'm looking for the official one. I think this is the one. In Apache, if you see, they have used the entry point. This is not official one, by the way. Let me check. This is the Docker file. So now if you see that, they have used this one. So now if you see that here, look at my screen, Docker come out of this container. Docker PS. Look at this very carefully. These all images, I took it used as a base as a Ubuntu. So you see the command bin bash, bin bash, bin bash. And these two containers, if you see, it's HTTP foreground, HTTP foreground. Here it is. So what I was trying to locate it. So guys, very important concept. This is the most important one. How to set, mind it, how to set container runtime. That means container will be running as long as the PID one is running. PID one, if you see that here, this is the container docker exec container ID, and you see here ps-ef. See, PID one is bin bash. So your container is running because of this PID one only. Okay. So now the question is how to set container runtime. That is the question. I'll simplify more. How to set container PID1, because PID1 only runs your container. If it is not running, it get exited because of some reason. Container also will get exited. Are you understanding, all of you?
Yes.
So the how to set it up? Answer is very simple. CMD or entry point. Yes, you can set the PID1 using one of these. Okay, so here you see that Apache people have set use the CMD, and if you see that other people, they have used, Jenkins have used entry point. If you see Ubuntu, they have used CMD, like that. So you have to, so if someone will ask you question, this is an interview question, by the way, what is CMD, what is entry point, you can say, see, containers to run, containers to bring in the running state, you need to have some container runtime which is set with the PID1, process ID 1. How to set the PID1 in any container? So for that we use CMD or entry point. Now next question they will say, okay, fine, good, but what is the difference between this CMD versus entry point? What is the difference between this? To mind it, in Ubuntu image, it has been used CMD. See the Docker image. Here, it has been used CMD. HTTP also, let me check. It has been used CMD also. But in a Jenkins image, they have used the entry point. So what is the difference between that? So let me download the Jenkins image. Docker pull. I remember that. Jenkins. So this image, you will have an entry point. Okay. So now what is the difference? So difference is, major difference. There's so many differences. I don't want to confuse you. CMD can be replaced. Okay. Entry point cannot be replaced. Very simple. I'm putting up, not complicating too much right now. There's few more differences, but it's not important. CMD can be replaced. Entry point cannot be replaced. How? Let me show you. So guys, look at my screen here. Docker run Ubuntu. Remember CMD is there, right? So Docker run -itd Ubuntu, and here I say ls. That means here I'm replacing it. Itd is not needed just for this demo because it will not be running because ls will exit. So Docker run Ubuntu ls. See that ls run in the container, and after that what has happened to the container? Look at this, exited. Why exited? Because ls got exited, so container got exited, but see, bin bash got replaced with ls. Look at this. So that means if you set up a CMD, it can be replaced with anything. See here. Are you understanding, all of you?
Yes.
But I said entry point cannot be replaced. Let me show you. So Docker run -d Jenkins. Jenkins has the entry point I showed you, and ls. Docker ps-a. See, this container got exited because of that parameter wrong, but not got replaced. User bintini, same. So that is a major difference. So in a nutshell, if I want to say, if you want to create certain image where user is allowed to change the PID1 and then use that image for the container, use the CMD. But if you want to create image where user are not allowed to create, replace the PID1, for example, Jenkins. When you download the Jenkins, you want to run Jenkins. Mind it. Simple logic. When you are downloading Jenkins, you want to run Jenkins, not Apache, not Tomcat. So Jenkins image developer are using entry point. But Ubuntu, you can use for any purpose. You can use for ls command, cat command, ps command, service command, running some Python script. Literally, you can run anything. So this guys is using CMD. Are you understanding, all of you?
Yes.
Yeah. So that is a major difference. So what I taught you is, first of all, in a little bit of detail about what is an image. So image is nothing but the collections of layers. Next thing, I taught you how to create an image using container commit command, docker commit command. Next thing, I taught you how to create an image using Dockerfile, and then some of the option of the Dockerfile using like from, container, maintainer, run, copy, env, user, this one, CMD, entry point, and all this stuff, and so on. Any questions so far?
Have any issues with our channel membership, you can drop an email to us at contact@devopschool.com, or you can also unsubscribe from channel membership anytime if you don't want to continue or did not like the video.
Please be kind enough to like it, and you can comment any of your doubts and queries. We will reply to them at the earliest.
Thanks for watching.